In the infinite canvas of our universe, life may have found a way to bloom, even in extreme conditions. Welcome to the extraordinary world of VHS 1256b. A celestial body that is as intriguing as it is distant. Hidden within its atmosphere is a world teeming with water, beckoning us to explore its potential for life. As we delve deeper into its secrets, we find an atmosphere unlike any other, challenging our understanding of what makes a planet. This celestial body, far more complex than anything we've seen before, holds within it the organic molecules of life, tantalizingly present in this otherworldly realm. VHS 1256b, a world that orbits not one, but two stars, offers a rare opportunity to seek extraterrestrial life. Its atmosphere, rich with water, methane, carbon monoxide, and even evidence of carbon dioxide, might just harbor the potential for life, sustained by the mysterious energy of its dual stars. But how do we decipher this cosmic mystery? Enter the James Webb Space Telescope, JWST, a marvel of human ingenuity, perched millions of kilometers from Earth. This telescope has opened a window to VHS 1256b's secrets. Did the cosmos just become a more intriguing multiplanetary life-supporting universe? Welcome to the Beyond. What sets this exoplanet apart is the composition of its atmosphere. In fact, this planet holds the distinction of hosting the largest number of identified molecules at one place outside our solar system. But the wonders of VHS 1256b don't stop at its atmospheric composition. Orbiting at a distance 4 times greater than that between Pluto and our Sun, the planet experiences blazing temperatures of up to 1,500 degrees Fahrenheit in its upper atmosphere, where turbulent silicate clouds create a mesmerizing spectacle. Brittany Miles, a talented researcher from University of Arizona, leads a team that is further investigating the mysteries of the enigmatic exoplanet's atmosphere. Miles's team uses Webb's near-infrared spectrograph, NIR-SPEC, and mid-infrared instrument, MIRI, to discover that the planet's atmosphere is in a constant state of flux, with a stormy 22-hour day that causes a continuous rise, mixing, and movement of its atmospheric content. This dynamic process propels scorching hot material upwards while pushing colder elements down, resulting in astonishingly dramatic fluctuations in brightness. In fact, VHS 1256b has earned the title of the most variable planetary mass object ever documented. However, more than 5,000 exoplanets were discovered by NASA over the course of this decade. Before the groundbreaking discovery by JWST, we believed that organic elements such as water were a scarce resource in the distant reaches of the universe, because liquid water requires a stable star system like our Sun and a rocky planet with a surface for water to accumulate and life to form. But the next planet quite literally resembles the planet from Interstellar. In June of 2022, an international team of scientists led by the University of Montreal announced the discovery of a nearby quote-unquote super-Earth exoplanet named TOI 1452b. Its location in the constellation Draco makes it an ideal candidate for the James Webb because the exoplanet orbits a red dwarf star, approximately 100 light-years away, which is a distance considered relatively close in astronomical terms. TOI 1452b completes an orbit around its star every 11 days. Even though it orbits very close to its star, TOI 1452b is still in the habitable zone because the red dwarf star is smaller and cooler than the Sun. As a result, the planet receives a similar amount of light as Venus does from the Sun, keeping the surface temperature moderate. Interestingly, it orbits not one, but two stars, a binary pair, each a red dwarf in its own right. This celestial dance is a slow, intricate waltz, taking the planet a staggering 1,400 years to complete a single orbit around its twin suns. Here's something interesting. The whole exoplanet has more water than our entire Earth. Seems like Nolan took some secret info from NASA, don't you think? The discovery was made using observations from NASA's Transiting Exoplanet Survey satellite, TESS, supported by ground-based telescopes. TOI 1452b is approximately 70% larger than Earth and about 5 times as massive. These characteristics suggest that the exoplanet could have a very deep ocean. The infamous quote-unquote water world falls into the category of ocean planets, which have long been theorized but have been challenging to confirm. Perhaps TOI 1452b could be a massive rock with little or no atmosphere, or it could be a rocky planet with a hydrogen and helium atmosphere filled with tons of water. Suppose TOI 1452b is indeed an ocean world. In that case, exoplanet simulations suggest that on this planet, water could constitute as much as 30% of its mass. This is comparable to the watery moons in our solar system, such as Jupiter's Ganymede and Callisto, Saturn's Titan, and Enceladus, believed to harbor deep oceans beneath their icy shells. A team led by Charles Cadieux, a PhD student at the University of Montreal, plans to schedule time on the James Webb Telescope to get a closer look at TOI 1452b. They want to capture a spectrum of starlight shining through the planet's atmosphere, which could provide a unique fingerprint of the atmospheric components. Seems like water could be a common link to connect distant exoplanets, which are potential breeding grounds for life and thus proving the theory of panspermia. This hypothesis proposes that life, or the building blocks of life, could have originated on one celestial body, like a planet, and then transported to another world, seeding life across the universe. It suggests that microorganisms, organic molecules, or even dormant life forms could have hitched a ride on comets, asteroids, or interstellar dust particles, traveling through space and potentially surviving the harsh conditions of space travel to populate other habitable planets. For example, the Chicxulub meteor, which wiped out dinosaurs 65 million years ago, was so devastating that when it struck Earth, the impact created millions, if not billions, of particles which were thrown into space. Alternatively, a similar event could have happened on a distant planet from which massive asteroids composed of pure water and organic elements were made. And then these space rocks of life traveled billions of light years to populate warm planets like our Earth. Perhaps the solar system's asteroid belt could help us understand the origins of life, because the following entry is possibly out of this world. The main belt region, situated between the orbits of Mars and Jupiter, is typically characterized by a vast collection of rocky and metallic objects known as asteroids. However, Comet Rhea defines the norm, emerging as a celestial outcast within this asteroid-dominated realm. Despite being in an asteroid belt, Comet Rhea periodically displays a halo and tail like a comet. Main belt comets themselves are a fairly new classification, and Comet Rhea was one of the original 3 comets used to establish the category. Before that, comets were understood to reside in the Kuiper belt and Oort cloud, beyond the orbit of Neptune, where primordial ice could be preserved further away from the Sun. Frozen material that evaporates as they approach the Sun is what gives comets their distinctive streaming tails, unlike their cosmic twins, rocky asteroids. Scientists have long speculated that water ice could be preserved in the warmer asteroid belt, inside the orbit of Jupiter, but definitive proof was elusive until James Webb's discovery The existence of water on a main belt comet is not the only secret Comet Reed has hidden in its core. The absence of carbon dioxide presents an even greater surprise. In the case of Comet Reed, the missing carbon dioxide is a baffling question that defies expectations. Typically, comets are composed of volatile materials, with carbon dioxide accounting for approximately 10% of their composition. Yet this celestial wanderer deviates from the norm, raising intriguing questions about its mysterious origins. Perhaps these latest breakthroughs by the JWST could be seen as a glimmer of hope, teasing the possibility that there might be places of habitable regions with a silent dread of realizing the existence of the quote-unquote little green men. Since its launch, the JWST has already made several remarkable discoveries, including capturing images of Glass Z10 and Glass Z12, two of the oldest galaxies ever observed, having formed just 350 to 450 million years after the Big Bang. Glass Z12 is the oldest, having formed when the universe was just 2% of its current age. It is located 13.6 billion light-years from Earth, surpassing the previous record holder, GNZ11, which is 13.4 billion light-years away. These galaxies were found in the Hubble Frontier Fields Cluster, Abell 2744, a group of about 500 galaxies, also known as Pandora's Box. Scientists use spectroscopy and redshift measurements to estimate the age of these ancient galaxies. The future holds exciting possibilities as we continue to explore the cosmos with the JWST as our guiding light.